All right, I've got another viewer-submitted puzzle here today. This was sent to me by thoughtbyte via my puzzle submission form, link in the description. And thoughtbyte said, this is rated 4 stars. I believe it is closer to a 3 than a 5. So as we've said before, 4 stars, a lot of the, with a 5-star range, a lot of the numbers are, have a lot of distance between the upper end and the lower end of like a 3. An upper 3 and a lower 3 can be a big difference. Same with the 4. So this is probably like a 3.5, sounds like. But I guess we'll find out. I don't know too much other than that. Let's pull the puzzle up here. This is called Kite Setting, and as I mentioned, it's by thoughtbyte. And I thought it looked pretty cool. You can kind of see how we have the kite. I think this is the kite up here, and then this is sort of like the tails hanging off the back, and I guess this is this kite string here, and maybe some sort of, I don't know, does it have like wings on it? I don't know enough about kites, I guess, to know what the different parts are, but that's how I see it. I guess you could even say these two dots are sort of eyes, and you have like a little smiley face down here, so maybe that's like a little kid running with the kite. I don't know. At any rate, I thought it looked interesting. Looks like a lot of fun. So our rules, we have all standard rules today. So we have arrows. The digits on an arrow must sum to the number in the circle. We have killer cages. Now, there's a couple of these that are a little bit different. So the killer cages, the number in the corner is the sum of the digits in the cage, and you can't repeat digits. But you'll notice 2 of them don't have sums in the corner, and we'll get to that in a little bit here, what that means. But if you don't know what that means, think about what that might mean and see if you can figure it out. Let's see. The white dot separates consecutive digits. The black dot separates digits with a 1 to 2 ratio, like 1 and 2, 2 and 4, something like that. And then we also have this diagonal thing. I think they're blue. The diagonals, you have to not repeat a digit on the diagonal. And that's it. So I'm going to give it a try now. Link in the description if you want to try it yourself. Banjo here's going to help, I think, today. Yeah, are you going to help or are you going to hinder? A little bit of both? Yeah, probably a little bit of both. Okay, so link in the description if you want to try it yourself. I'm going to give it a shot now. We'll see how it goes. Let's restart the timer. And all right, we are off. So the first thing I'm going to look at is these cages without the numbers on them. So we do know the sum of these cages, even though there's no number in the corner, because you can't repeat a digit in a cage. So these must contain all 9 digits, 1 through 9, and the sum of the digits 1 to 9 is 45. This one is the same way. It's 9 cells, so the sum is 45. So really what these cages are doing is just telling us these are really like an extra region. They drew them as cages, probably because they already had cages in the grid and because they thought it looked better. But really, you could make this just an extra region and it would be the exact same thing. This one too. All right, don't chew on me. Don't chew on me. He's big, but he's still a puppy. So what I'm thinking now, I think there might be a clue to what we need to do in the title of the puzzle. Actually, you'll notice it's called Kite Setting, and so I suspect we're gonna need to use set. This looks like a puzzle we'll need to use set on, anyways. If you're not familiar with set, I did do a brief video kind of explaining what set is, so I'll leave a link to that in the description as well. You could also look up there in the corner. Maybe I'll put a little card up there for it. But if you want to go check that out and come back, I'm wondering what, I mean, we've done some stuff with set before using the diagonals. And that kind of looks good with the arrows, but the problem is we've got like the circle and one of the arrow digits on the diagonal. And we need the circles to be separate from the arrows if we're going to use set, typically, how we typically use set. You know what I'm thinking? I actually think these cells are the same as those. Those digits are the same. And the reason I think that, okay, we're going to use set. This is going to be an easier set, I think. But we're going to use set to prove that those digits are the same. So let's see. Let's color. I'm going to color these 4 columns. Let's make those purple. So these are obviously 4 sets of the digits 1 through 9 because they're 4 columns, and every column, row, and box is a set of the digits 1 to 9. Then I'm going to do these 5 rows. We'll make those, I think that's yellow. So there's 4 sets in the purple, 5 sets in the yellow. But we know this is one set of the digits 1 to 9 right here. So if we remove that, we've removed one set from the yellow. So the yellow now contains 4 sets. The purple contains 4 sets. And so all of these cells right here that are in the yellow and the purple, you can kind of think of it as, it's like algebra. If you had purple on one side of the equation and yellow on the other side of the equation, and they were equal, purple equals yellow. If you divide both sides by 2, for example, then the 2 sides are still equal. If you subtract 5 from both sides, they're still equal. Whatever you do if you do the same thing, same operation to both sides of the equation, you still have the correct equation. And that's what we're doing here. We're removing these 20 cells from the purple and from the yellow, from both sides, the same amount. We still have an equality. So if I do that, this purple still equals this yellow. And now remember, this is all the digits 1 to 9 in this cage, and this box is all the digits 1 to 9. So if we remove the same set of digits from both sides of the equation, there's still an equality. So these equal these. And these all have to be different. Or do they? This one could be... The circles can't be the same. No, they do have to be different. Okay. yeah. Sorry. So we know on a one cell arrow, because the arrow digits have to sum to the circle, and there's only one cell, they just have to be the same. These two are the same digit. And I was saying, oh, these have to be different because they both are also on their arrow in the same box. But then for some reason I was thinking this could be up there. But no, it can't for the same reason. So you could essentially move those 2 cells in here because they're equal. And now you can see all the purples are in the same box. They obviously have to be different digits. Therefore, these have to be different digits. And so I'm wondering if there might only be one way to do the 11 cages. Well, I mean, we won't know which is which, but I suspect, because do you have to have a 1 or a 2? If you didn't have a 1 or a 2, the minimum you could do is 3, 4, and 5, which is 12. So you do have to have a 1 and a 2. So there's a 1 in one of them and a 2 in the other. And we don't know which is which, but I'm just going to write it this way for now just to see. I want to figure out what the options are. So with 1, you need 10, and it can't be 1, 9, or 2, 8, because remember, we can't repeat a digit in here. We've already got a 1 and a 2. So it can't be 1, 9, or 2, 8. So it would have to be 3, 7, or... here, let's do this. Let's do 3, 7, or 4, 6. I'm just writing out our options. If we have 2, we need 9. It can't be 1, 8, or 2, 7, so it would have to be 3, 6, or 4, 5. Yep, and if you have 3, 6, then both of these options are eliminated. So it's got to be 4, 5. So we got to have 2, 4, 5, and then therefore we can't do 4, 6, so it's got to be 1, 3, 7. Now, we don't know which is which. These two could be swapped, so I'm going to write them like this for right now, as opposed to, 2, 4, 5, and all of here. So that way it'll hopefully help me remember that this isn't 1, 3, 7 necessarily. It's just these are the 2 options for the 11 cages. So what we know, and we know this is 6, 7, 8, or 9, because a 3-cell arrow, minimum is 1, 2, 3, which is 6. But this can't be 7, because we know there's a 7 in one of the 11 cages. So this is a 6, 8, or 9. So these digits are the same as the yellow. So they have to have 1, 3, 7, 2, 4, 5, and then a 6, 8, or 9. Now, the 6, 8, or 9. Yeah, it could be anywhere, though, couldn't it? If this was 7, you could put a 6 in here. You couldn't put an 8 or a 9 on these arrows. But we could put a 6 on those arrows. And if it was 8 or 9, it could be there. And obviously, they could be here. Wait, no. No, the 6, 8, or 9 can't be in the circle. Because remember the diagonal constraint. They're both on the diagonal. So whatever digit is here can't be there. But it could be on the arrow if it's a 6. But we do know this is, oh, this is at least 5. Because these, the minimum you can do in these 4 cells, since you can't repeat a digit, is 1, 2, 3, 4, which is 10. And so half of that, since this circle is, you know, the 2 arrows are double the circle when you add them together. So this has to be at least 5, but it could be 5 or 7. But we can't put a 7 on the arrow. Either way. Let's see. If it's 5, it's 1, 2, 3, 4. If it's 7, it's going to be 2, 5, 3, 4. So there's a 2, 3, 4 on these arrows no matter what. So these can't be 2, 3, 4. There's a 5. There's either a 5 in the circle or a 5 on one of the arrows. So these can't be 5. So these are either 1 with the 6, 8, or 9, or they're 7 with the 6, 8, or 9. And those are in here. So where does the other 2 of the 6, 8, and 9 go? Whichever one is in this circle is on one of these. And the other 2 have to be in here. So that's 6, 8, 9, which gives us a 6, 8, 9 triple on the diagonal. Hold on, I could blow my nose, sorry. Okay, back to it. Sorry, I could feel things running and I knew it was going to become a problem. Okay, so we got our 6, 8, 9 triple on the diagonal here. So, which means these cannot be, so normally with 9 you could do 1, 2, 6, but we can't. So these have to be from 1, 2, 3, 4, and 5. This one can't be 5 because of the black dot. Okay, what about this one? So this circle has to be, it's kind of like this one up here, right? We have to have 2 sets of 2. So it has to be at least 5. Because again, 1, 2, 3, 4 is our minimum, which is 10. This has to be at least 5. And it can't be 6, 7, or it can't be 6, 8, or 9. So it's a 5 or a 7. So now we can't put a 5 down here either. And in fact, this is a 1, 2, 3, or 4. Can this one be a 1? I don't think it can. Because if this is a 1, the white dot needs a 2, the black dot needs a 2. This can't be a 1. Can it be a 2? You would have a 1 or a 3 here. No, you can't. Because if this is 2, the only things you can put on these dots are 1, 3, or 4. But we can't use 2. If these were 1, 3, or 4, you'd have 5 cells that would all contain 1, 2, 3, and 4, which is impossible. So this can't be 2. It's got to be, yeah, if it's 3, it would work. If it's 4, it would work, because you could put a 6 or an 8 over here. Or even a 2 with a 5 if that's 4, I guess. Okay. So, now what do we do? Okay, so we know, I'm going to get rid of that coloring because we've already used, I think we've done everything we can with it. We know that these are, you know, equal. So what I want to do is I want to color these instead. So let's go with, I think that's red and blue. Let's do red and blue. Cubs colors. All right. So the blue has to be over here, and the red has to be down here. The problem is we just don't know enough about those yet. We know one of them is a 6, 8, or 9, and one of them is a 1 or a 7. And clearly the 1 couldn't be in the circle. But the 1 could be on the dots. The 7 and the 9 couldn't be on the black dot, but could be in the circle and could be on the white dot. Okay. Oh, no, in here, look, the 5. Now that we know this is a 1, 2, 3, or 4. So if this is 5, what are we putting on here? 1, 4, and 2, 3. There's nothing that can go in that cell. This has to be the 7, which means this is the 5. Okay. And so those are 1, 2, 3, and 4. These are 7 with 6, 8, or 9. So one of these is a 7. And we just said it can't go on the... Yes, okay, perfect. If the blue is the 7, where's the 7 go over here? We can't put a 7 on a black dot, because a 1 to 2 ratio, you'd have to have a 3.5 or a 14, which are both ridiculous in a Sudoku. So it couldn't go there. It would have to go on the circle, but look, it's on the diagonal with another 7. Oh, that's genius. Okay. All right, so 6, 8, so these are the 7. It can't be in the circle, so it has to be here with a 6 or an 8, and now we've got 6, 7, 8, 9. There has to be a 9 up here. And we've got 6, 7, 8, 9. So these are 1, 2, 3, 4, and 5. This one can't be 1 or 2. Could it be 3? Yeah, I think it could, unfortunately. So this is 6, 7, or 7, 8. So that's 6, 9, or 8, 9. This one over here. I mean, if it's 9, we know it's on the circle, but the 6 or the 8 could be in here. But look, 7, 7. There's a 7 in this cage, so it is the opposite of what I was thinking. So it's this way. These are 1, 3, 7. These are 2, 4, 5. Because the 7 has to be down there, which means we have a 7 down here, for whatever that's worth. And a 7 up there. Okay, I think we need to look maybe in here now, because we've got some more information about what's going on with these. So what... well, I guess we should do this. We should get rid of the 1 and 3 there, right? Oh, you know what? This is sort of like a little mini set here, because these are the digits 1 to 9. These are the digits 1 to 9. These 4, if you remove those 4 from both sets, they're still equal. So these 5 have to equal those 5. So these are 1, 2, 3, 4, and 5. The problem is there's 3 options for 7. You can do 1, 6, 2, 5, or 3, 4. So we know that the 8 and the 9 are in here. So one thing we can say is the 8 and the 9 are both in here, and this one is actually the blue, right? That's the same as this one. Because this one can't be on the diagonal, so it can't be either of those, so it has to be that one, which is there. Those 2 blues. Put a blue down here somewhere. And the other 8 or 9 has to be in one of these two, so we can't put an 8 or a 9 in there. So the 8 and the 9 are both in that. The 9 obviously can't be on the pointy end of the inequality. That has to be smaller. So... but I mean, I guess we could have figured that out just by looking at the rest of the row and seeing there's no 8 or 9 in there, but... okay, so this can't be 2, 4, or 5. This can't be 1 or 3, so that's something. If that can't be 1 or 3, this can't be 6 or 4, because it's the counterpart for the 7. This can't be 2, 4, or 5, then this can't be 2, 5, or 3. So the 2, 5 can't be here. If we have a 2, 5. I guess we don't even know we have a 2, 5. It could be 1, 6, 3, 4, couldn't it? Oh, right, down here. So we don't actually have quite as many options as I was thinking, because what happens if we don't have a 3 down here? Then we have 1, 2, 4, which is 7, and we can't have 7. It's got to be 6, 8, or 9. So we have to have a 3 either way, which means this one can't be 3. So this is a 1, 2, or but if it's a 4, you could put a 3 in here maybe? Could that be a 3? Just wondering if because we have 1, 6, 2, 5, and 3, 4 as options. We have to use 2 of them. And so 2 of these are going to have a 1, 2, or 4, and the other 1, 2, or 4 is going to be there. So that's all of our 1, 2, and 4. So this is going to be, there's an 8 or a 9 in one of these two. To go, well, or they could both be 8, 9 if this is 6, I guess. 6, 8, 9. These would be 2, 5, and 3, 4 with the 1 in the corner there. But it's the 3, 5, and the 6 that have to be in. One of the 3, 5, or 6 has to be in here. This one can't be 3. This one can't be 5 because of those cages. This is very interesting. I'm wondering if there's another set I should be using. I'm just not seeing how. Hold on. He's chewing on something he's not supposed to. All right. Like I said, he's still a puppy. He's really good about not chewing on things that aren't his toys 98% of the time. But for some reason, every once in a while, he'll grab something he's not supposed to. It's usually something that looks like a dog toy. So, you know, I think he just gets confused. All right. So what do we need to do now? What do we need to do? Well, let's think about what needs to be in here, or what. So, what's in here? Do we know what's in here? All right. No, I'm not gonna think about that. I want to look back up here. So, if this is 3, 4, what happens? There's a 3, 4 up there. These are 1, 2, 5. And this is 2, 5, or 1, 6. Okay, that seems fine. If this is 1, 6, seems like that's okay. There's got to be some reason why it doesn't work, but I'm not seeing it. So we know there's an 8 or a 9 down here, an 8 or a 9 here. Okay, so these can't be 1, 3, or 7. And they can't be 8 or 9. So they're 2, 4, 5, 6. And they have to have 2 and 4. Because where else can you put a 2 and 4 in this cage? You can't put a 2 or 4 down here. You can't put it in here. The 2 and the 4 have to be in here. So this can't be 2, which means that's not 5. Okay. Something. And then, okay, and so that also means this is 8, 9 with a 5 or a 6, because whichever one is not in here has to be up here. which then means if this is 1, 6, you have the 5 over here. So you move this becomes 2, 3, 4 across there. And these are 1, 5 then. Which means if this is 1, 6, this can't be 2, 5. This is 3, 4. If it's 1, 6, then it's 3, 4. If it's 3, 4, this is 1, 2, 5. This is 3, 4. Can this still be 1, 6 or 2, 5 then? If this is 3, 4, you get 1, 2, 5. This would be 6, 8, 9. This would be 2, 4, 5. That would not be a 5. Oh, that's it. Yeah, that's what we need. Look in this box. Okay, an easier way to see it. That was a roundabout way of seeing it. There's a much easier way to see it, but it helped me find it. Where in this box can we put a 5? We have 2 options. The 5s are in one of those 2 spots. Both of those see these 3 cells. This one sees them in the row. This one sees them because it's in the same cage. The 5 is in one of those 2. Either way, this cannot be a 5. This is 2, 4, 6. This is 5, 8, 9. And that 6 means these are not 6, which means we have to have a 1, 6. Do we have to have a 1, 6? We don't have to have a 1, 6. Yes. Oh, right. Before we said you could put the 6 here and the 8, 9 could be in those 2. But for that to happen, there would be no 8, 9. If these were both 8, 9, you couldn't put an 8 or a 9 in here. Both 8 and 9 would have to be in here, but one of them has to be... Oh, but that would be the 6. Never mind. This can be a 6. Right, because that would then be a 6. Yeah, okay. So that works. So we don't have to have a 1, 6 in here, actually. I was thinking we did because of not putting a 6 in here, but this can be the 6. This is weird. Okay, but the 5, 8, 9 means these are not 5. There we go. These are not 5 because of the 5, 8, 9. So in this set of 5, the 5 has to be there. This is not 5 and 2. These are 1, 6, and 3, 4. This is a 2. This is not a 3. This is a 5. This is not a 6, which means these are not 6s. Which means what? This is 1, 3, 4 or 2, 3, 4. So there's definitely a 4 in here. Oh, and there's... Right. No, we know what it is because there's no 2. So it's 1, 3, 4, which means this is 8. There we go. That's what we needed. This is 9. We need to put an 8 over here. I was hoping it was going to be a 9 and we could force it into the circle, but the 8 could be anywhere in there. These have to have a 5. One of these... Oh, these are not 2. One of these is 3, 4. Because this is a 5, it has to be the 1, 5. Because you're either going to have a 3, 4 here and 3, 4 there, or a 3, 4 here and there. And whichever one you put the 3, 4 in, the other one's going to have to be 1, 5, and you can't put a 5 in here. So this has to be the 1, 5. This has to be the 3, 4, which means that's the 1, 6. This is the 3, 4, which goes in that order because of the 4 and the 3 in those. Okay, this is not 3. This is not 4. Oh, this is not 4 either because the 3, 4 in the box. So we know these then. These are 6, 7, and 9. And because of the inequality, it's sort of like a short thermometer there. Oh, we can do the same thing over here. Okay, these are 1, 3, and 6. No, that can't be right. No, not 1, 3, and 6. 1, 3, and 8, sorry. But the 1 gives us the order of the 6 and the 1 there. This is a 9, because the 8. Okay, so we know what these are. 3, 6, and 7. These are 2, 4, and 9. Just finishing the columns there. This is not 9. That's not 7. This is not 6. Okay. Now, oh, the 8 up here. The 8 means this is a 6, 7. Okay, I'm gonna get rid of all of the colors now. So we have a 6, 7 pair here. So this can't be 3 because you'd have to have a 6 on the dot. So this is a 4. 4. Now this can't be, this has to be 3 or 5. It can't be a 3. It's got to be a 5. This has to be 2 or 8. Oh, and it can be either one, can't it? But the 5 here makes this an 8 and a 9 and a 5, which doesn't help us there, like I was hoping it would. This is not a 4. The 4 here means that can't be a 4. So can this be a 3? If it's 3, because of the 1, it would have to be 2, 1. If it's 5, it can't be 4, 1. It would have to be 2, 3, which works, I think. Okay, what about this one? It obviously can't be 1 or 2. It has to be at least 3. Could be 3. Can't be 4 because the diagonal. Can't be 5. Could be 6. It can't be 7 or 9, but it could be 8. So it's 3, 6, or 8. If it's 3, this would have to be 1, 2. If it's 3, this would have to be 2. That would make, if this was 3, that would have to be 2. And then what would you put there? You can't do 3 and 2 because there would be nothing there. So this can't be 3. Now, if it's 6, I think it's got more options. Well, it would have to be 5, 1, or 2, 4 in that order because of the 1 and the 4 here. And it can't be 5, 1 because of the 1, 5 there. So it would have to be 2, 4. If it's 8, it couldn't be 1, 7. Could be, can't be 2, 6. Could it be 3, 5? It would have to be like that. If it's 8, it could be 3, 5. So this is 2, 3, or 4, 5. Okay, so there are 2 options there. Oh, but this is a 2 or a 3. So now you can't make this 3, 2, 1 because you'd have 3 and 2, and it would eliminate both options from there. So this is a 5. 2, 1. These are not 1 or 2 then. This is a 2, 3 pair, so that's 4 and 3. 4. That's not 4. This is not 2 or 3, so it's a 1. That works out well. We needed a 1, 4 on one end and a 2, 3 on the other end. We've got a 2, 3 pair there, so this is 7. This is not 2. This is 1, 4, or 9. What about this dot? It can't be 3, 6 because if you put 3 and 6 on here, there'd be nothing in there. So this has to be from 1, 2, 4, and 8. And it can't be 2, 4. So it either has to be 1, 2 or 4, 8. And if it's 4, 8, this is a 6, which has to be 2 and 4, which doesn't work. So this can't be 4, 8. This has to be 1, 2. 4, 9, 2. And now my Roomba, I've got all kinds of interruptions today. We're going to pause. Okay, my Roomba decided to start going, so this is just distraction day. All right, 1 and 2 makes this a 5 and a 1. This is not a 1, therefore. Oh, the 9 makes that a 4 and a 5. Therefore, this is 5, 3, and 8. And the 3 gives us 2 and 3, which gives us 6 and 3. And this can't be a 3 anymore. So we get 2 and 3. That 2 makes this an 8. The 3 makes this a 1. Therefore, this is a 3. The 1 gives us the order of the 1 and the 2 there. That can't be 2. This can't be 4. So we got 2, 6 pair. This is 4. This can't be 1. So we have a 3, 7 pair. That's a 1. Up here, 6, 7, and 9. That one can't be 9. This is 6 or 7 as well, which gives us a 3 because of the 6, 7 pair. This is a 7. That's not a 7. Okay, what's over here? These are 5, 6, 8, and 9. These can't be 9 or 6, so those can't be 5 or 8. And the 6 up here, this 9 and 6, the 5 up above gives us the 5 and the 8. The only thing left in this row is an 8. That's not an 8. let's see, this column needs 1, 4, and 9. Oh, we also have the diagonal here. The 7 gives us the 6. This is not 1 or 4, it's a 9. The 4 over here, fix the other ones. So this is not 1, that's not 2, this is not 4, so it's 5. This is not 4. This is not 3 or 1, so it's an 8, 3, 1. This one's not a 9, so it's 7, 6, 9. That gives us the 7 and the 6 there. This is, oh, look up here. The 6 gives us 7 and 6 for the row. These are 2 and 9, and the 9 over there will give us the order. That 2 is going to give us 6 and 2. This is no longer a 6 or a 9, so it's a 7 and a 9. Looks good to me. Timer stopped. There we go. All right, that was a fun puzzle. It was interesting. It did use set actually a couple of times, but they weren't real complicated sets like sometimes they are. I mean, it was a little bit complicated, but not like some sets that we've done where you've got all kinds of crazy things going on. So this one was interesting because I think this is, you know, once you kind of get the idea of what set's doing, this isn't a super hard to understand set right here. And then removing that and these, that's not too difficult. It's not super easy, but you know. It's interesting, you know, I think so we know this is I didn't use this, but I'm looking at this now. This is 1 to 9. This is 1 to 9. Now we're repeating this middle digit, right? But these 8 digits are one set of 1 to 9 minus that 7. These 8 digits are one set of 1 to 9 minus that 7. So these, you could actually say that these, the purples equal the reds there. Which is interesting. So the purples equal the reds, but also, you know, the column equals the row. And so, yeah, and so, yes, from there, and we can see this is true, actually, now that we have the grid filled, but knowing that this equals that, and this equals that, so we can say these 4, or these 8, sorry, are a set of the same digits. And so what am I trying to say? Right. So what we can say is actually, that's what I want to say. These are the same. The yellows are the same, and the blues are the same. Here, maybe instead of that, let's call it blue and purple. The blue equals the purple, and the yellow equals the orange. How about that? And we can see that that's true in this situation. Now, this only works because of this cage. I don't think if you have that cage, don't have that cage there, I don't think it works the same way. But because of that cage, we can say that the blue and the purple are equal, and the yellow and the orange are equal. And so I think from that, using set, we can actually say that these equal those. I think we can say that the gray regions are the same digits. And these, should we make them red? The red regions are the same digits. Now, is that true? It is true, and we know that's true because we already proved that this equals this, and we know that that cage equals that box. So we know the reds are equal. And so the grays must be equal too. That's interesting. So equal in that they contain the same digits, not equal in that they, the digits aren't in the same order, right? The 6 and the 3. But we have, for example, we have 2 7s in the gray, and we have 2 7s in the other gray. We have 2 7s in the red, 2 7s in the red. We don't have 2 of every digit, though, because we know we have 1 of every digit in the box, and then these are just 7 of the digits. So we only have 1 2 in the gray, for example. Oh, wait, we have 2 2s in the gray. Those are not equal. Interesting. The grays are not equal. Okay, so looking at this again, I can see why the grays were not equal, and so I wanted to explain to people what's going on here. So if we get rid of the reds for a second, actually, we'll just leave the reds. So here's the thing. If we look at these 4 rows and these 4 columns, we know that those are both 4 sets of the digits 1 to 9. And we know that the yellow equals the orange. We've proved that. So we can remove those from the columns and from the rows. And so now we know that these and these are equal. So we can remove the overlap here, and we get that the reds are equal. Okay, we can prove that. But the problem is, if we try and do it the other way to show that the grays were equal, remember we had the grays in here, we can use these 4 rows again, and these 4 columns again, and we can remove this overlap, right? But we can't remove the orange and the purple, blue, whichever color this is, because these are not equal. So we get that this, okay, let's delete the colors for a second. So actually what we can say is these, the yellow, equal the red. But we can't then remove these cells, which is why what I had colored gray was not equal. So there you go. Just wanted to throw that in there. But all right, let me know what you thought of that puzzle. How'd you do? Did you do it faster, slower? Were you able to finish it? Did you find the set? Did you find a different set that was helpful? There could be another one. I don't really know. But I hope you guys enjoyed that. And don't forget to like and subscribe. And I'll see you again soon with another puzzle. Thanks. Bye.